Hello, everyone. Today we're going to be presenting our project ZoomGPT, which is consisting of fine-tuning of large language models to be able to more accurately create a question-answer platform for properly parsing through meeting transcripts. Now we're going to go over a brief overview of what we're going to be talking about. First of all, it's going to be the business problem, where we're going to be focusing on what we're actually trying to solve. Then we're going to go through the process we took to make this project a reality. Then we're going to specify and go into specifics of how we fine-tune the LLM. We're going to do some model validation to figure out how accurate the model is. We're going to talk about some future steps we may take to take the project to the next level. And finally, we're going to go over some costs of what the whole project took to be made into a reality. And I'm going to pass it on to Ahlad to focus on the business problem.
So our key motivation to pursue this project came from the fact that meetings have a lot of unstructured data, even if it's being held virtually or in person. And a lot of that unstructured data can lead to missing a few critical points that were being discussed in the meeting, or it can also lead to information overload. The other aspect of it is that it can be time-consuming to extract relevant information from such transcripts. And that's why we want to address these business problems. Moving forward, the scope of our project essentially deals with fine-tuning a large language model to accurately respond to user questions without having the user to search through the entire transcript of a meeting. Now I'm going to talk about the process a little bit. Initially, we obtained meeting data through a corpus of a lot of meeting recordings. Then secondly, we used the GPT-4 Turbo LLM to create a synthetic data set consisting of question and answer format. Then we also formatted the synthetic data set to fine-tune our model that was on the Together.ai platform. And lastly, we did evaluation of our fine-tuned model using a validation set. Now I'll pass it on to Will.
Thanks a lot. So let's talk about our data. We started with the AMI meeting corpus, which is a corpus of audio recordings, 100 hours about, and about 171 different meetings about remote controls. And we use that data to then create 855 question and answer pairs, 5 for each meeting, generated by GPT-4 Turbo. And then we manually created a 100 question answer pair data set for validation by manually creating questions about transcripts and then answering them. And then what we did was we benchmarked our GPT-4 Turbo performance versus our fine-tuned model's performance on those manually created question answer pairs. So now I'm going to talk about our synthetic data set. So again, our synthetic data set was generated by GPT-4 Turbo. It was the 0125 preview edition, and we used that to generate 5 Q&A pairs with all the given transcripts. And we chose GPT-4 Turbo because the transcripts had, some transcripts needed the larger context window compared to the GPT-4 model. And for the system prompts, we asked the model to be a helpful transcript summarizer designed to output 5 questions and answers in the meeting transcript from a meeting transcript, and then format it. And then for the user prompt, we just use the transcripts we had. And so now I'm going to pass it to Yoav to talk about fine tuning.
Thanks, Will. Okay, so for fine tuning the actual model, we went through a few steps. First of all, we had to create a system prompt. This included the transcript itself to give context to the system, but it also allowed for us to fine tune a little bit how the model would act. So we wanted it to be succinct and deal only in facts, and just to be clear if something wasn't explicitly covered in a meeting. We took all of that system prompt and we put it into a JSON-L file where each question answer pair was its own JSON line, where we had the system prompt as well as the user question and the expected answer. We fed that whole file that we created into Together.ai to do the fine tuning. And once that was done, we compared the performance of our model that we fine-tuned, which was a wrapper of Llama 2 that Together.ai created, which had some larger context token space, which allowed us to actually use these big transcripts. We took all that and we compared it with other models that came out of the box using Spacey. We did this because the answers are pretty open-ended and unstructured, and so doing something like document similarity made a lot of sense. So speaking of the model validation, these are our similarity scores that came out based on our validation set that Will touched on. So GPT-4 kind of did the best here. With our limited data set, though, we managed to take the base Llama 2 model that we spoke about and increase its performance to be almost near where GPT-4 in the state of the art currently is. With more data, we would expect to actually be more successful than GPT-4 itself. But to dive into our model's performance a little bit more, I'll pass it on to Chad.
Well, thanks, Yoav. So fine-tuning with Together AI is really good because they partner with Weights and Biases platform to offer users insights into their model's performance. Visualizing model performance is really essential for understanding how your model behaves and understanding its performing metrics. So for us, assessing how our model learns from the data is extremely crucial. For example, by using this platform, we were able to learn that our loss started around 2.6, but by the end of it, it ended around 1.2, demonstrating that our model learned through each iteration. This platform that we use is specifically known for two key features, logging and visualization. So we log the relevant metrics, and then we can view them on the dashboard and create interactive visualizations to explore the performance and diagnose any features. Analyzing these graphs provides insights into models such as overfitting, underfitting, and other performance issues, allowing us to improve model performance. So now I'll talk about the benefits of fine-tuning. So efficiency, flexibility, context, accurate, and versatile are key features that we noticed while completing this project. It's efficient because it makes your searches a lot faster. Fine-tuning allows you to leverage pre-trained models that already have learned generic features from large data sets. So it reduces the computational resources. They're flexible and versatile because fine-tuning provides very adaptive trained models to specific tasks or domains to incorporate the context within the domain-specific knowledge. So you really capture the relevant target domain. And finally, it's accurate because it helps improve the accuracy of models by adapting them to the nuances of the target task or data set. So by fine-tuning on task-specific data, we can fine-tune models, parameters to better capture relevant features and relationships. And I'll pass it off to Jacob to talk about the applications.
Sweet, thanks, Chad. So some of the applications we talked about when creating this project was it can be used for businesses to help provide like meeting summaries and answer specific questions by employees that may have missed the meetings or maybe had a little bit of information overload that Ahlad talked about earlier. It could also be used for school if students have to attend class virtually or they miss a class virtually due to extenuating circumstances. They can ask questions that they may have missed or get clarification from difficult concepts that they may not remember the teacher covering. It also could be used as a personal device to help you remember things that you discuss with people, which just helps with like family planning and outings and stuff like that. And then some of the next steps we could take when training this kind of model or when using these models kind of in the future, we can include higher quality data to improve the performance of the model. Like Yoav mentioned, we got pretty close to the performance of GPT-4, and with a bit more data that is both higher in quality and quantity, we could definitely surpass or definitely have a chance of surpassing the ability of GPT-4. And then also we could continue with integration to Zoom or any other online meeting apps. And actually in the next slide, we can see there's an architecture diagram that shows this. We just transform those audio recordings into using a speech-to-text API like Whisper, convert that sound to text, and then run those scripts through the Together AI model that we created, fine-tuning that model, and then allowing people to query that model and get answers to their questions that they may have. And with that, I'll pass it off to Poon to cover the rest of the next steps and some of the costs we have.
In order to improve the performance of our model, first, we need more data. By adding the wider variety of contexts and questions would lead to better model performance. And next, we need more to increase the quality of our context, like by incorporating question and answer from domain expert. The model can align its understanding and output with the field's current standard terminology and expectation. And for the cost, we spend around $40 to develop this model. For the first $15, $14 to generate a synthetic dataset. And we use almost $20 to do the fine-tuning and to do the benchmarking against ChatGPT-4, we spend around $5. And thank you for listening. And you can read our full article at the link below. Thank you.